Hello everyone. So today we will learn some examples of DFA. How to design a DFA, what are the requirements. Okay. So here we have already seen what is the definition of DFA, what are the things required for the DFA, right? So M is equals to Q. Q is the number of states represented by a circle, and sigma is the alphabets of the circle, that is the input symbol, and delta is a transition function from which input the transition is taking from which state to which state, and q naught is the starting state with an arrow, and f is a final state with a double circle representation. Okay, this is how what is the definition. We call it as a DFA definition or a 5-tuple definition of a DFA. Okay, and one more thing, DFA is a deterministic finite automata, means finite number of states it contains, and deterministic means for the given input it will take the transition. Okay, so here DFA, to accept a empty language, L is a capital L is representation of the language, and this is a set of symbols in the language. 5 means it is a null set. Okay, you know right, 5 means null. So here, so starting state only contains q naught. It is not been accepted because it's a null string, null, right? So q naught only is there. We are not accepting, it is not been accepted, so we can't represent with a double circle. Okay, and here epsilon, this is an empty string. Null string is different, it's an empty string. Okay, empty string, accept a empty string. So here it is having accepted, it has to be accepted, so we can represent with a double circle. Okay, and the next one is DFA to accept exactly 1A. So means what? Our language should accept exactly 1A. So starting state, final state, and the transition should be A. Okay, so exactly 1A it is represented like this, and the DFA to accept a string A and B, so it is represented like this, means two transactions we have to design. So q0 to q1 with the input symbol A, and q1 to q2 then input symbol B, and if it is accepting A and B, then it should be in the accepting state. So this is a simple representation how we are representing the for the particular string. Okay, so next one we have any number of A. So here A star means it can be epsilon A, 3A, so it will go on like this. So minimum string is epsilon. When we are inserting epsilon, what we have to write? We have to write like this way, right? So same way you will write, and any numbers of A means we are looping itself. So here it may have empty string, single A, double A, triple A, so it will go it can be have any number of A. So this is a DFA to accept a string consisting of any number of A. So this is our transition diagram. Similarly, any number of B, this is a transition diagram, and A plus B star means any number of A's and B's. There is no rule that like this only the appearance of A and B in any of the order. So here there is no order. It can be A, B, epsilon, okay, single A, single B, AA, BB. So it can be any way, any number of A's and any number of B's that is represented by AB star. So this is your transition diagram for that particular string. So this is a regular expression. We call this as a regular expression, and this is our transition function. This is transition diagram. Okay, now we'll see some problems how to design the DFA which accept the strings of at least 1A. Okay, so they are given at least 1A. So as they mentioned, it is DFA, so every state should take a transition. So here sigma is A. Okay, sigma is A means only one input symbol is present, and this is our DFA. M is equals to Q sigma delta Q naught and F. Q, the number of states. To accept at least 1A, we need a two states, starting state and ending state, and Q0 to Q1, you have a transition A. Now if you see here, the minimum number of input it is accepted is A, means minimum 1A it should contain. That is our question is at least 1A, right? So minimum is A. Next it may contain 1A with any occurrence of A. So A, again A. So like this it may contain any number of A. So minimum is at least one A. It will be accepted followed by any occurrence of A, right? So that we represented by A star here. Okay, so any occurrence in the loop. So it can be have any occurrence of A. So this is being accepted for our problem, that is at least one A. Okay, so for this one Q is a set of all the states. So set of all the state is Q0 and Q1, only two states we have, that is, and sigma is the alphabetic symbol. So here only one alphabet, that is A. Next Q0 is a starting state, starts with an arrow and the circle. So Q0 is a starting state, and the F is the final state represented by double circle, that is Q1. Okay, and your transition diagram, the transition is being represented in the transition table. Delta is a transition function, A is the input symbol, that is sigma, and this are the transition. So starting state represented by an arrow, and the star is the representation of final state. Now Q0 for A. Q0 for A, it is taking transition to Q1. So you will write Q1, and Q1 for A, it is taking transition to itself. So we will write Q1. Okay, and for this one, if you want to write the transition function, another way of representation, delta Q0 for A, it is moving to Q1, and delta Q1 for A, it is moving to Q1. Okay, this is how you can write the transition function. So either one of is enough, either you can write the table or the transition function for the given problem.